Bam. We're being recorded. That means it's time to start on some unit number dos. Let's get this thing going. Welcome to class, everyone. If you forgot who I am, my name is Kyle. And by the way, these slides are prepared for people who are coming in also from the new class. I don't think we have any new students here, so you're just going to sit through, and I'm just going to talk about myself, because why not? Because that's what I'm supposed to do, apparently, for every unit. But if you didn't know who I am, yes, I am Kyle Wegner. That's with a W. Yep, E between everything. And so I was also supposed to say, like, okay, what's my technical background? Do a rant on that. So I work at Bayer. As you already know, I worked at other places. I've been doing this since 2018. Look at that. And I know things. Yes. Kyle's teaching you about me bragging. That's right. This is also, there's a test on this, so please take notes about me. It's all about me. All right. And I put this little joke in here because I'm usually talking about myself for a bit, but I'm like, they don't care.
There seriously is a test.
All this is gonna be on test. Everything's fair game. This assignment 1 is all about Kyle. All right. Dog wants a dog, obviously. I've literally gotten posts saying, stop talking about dogs, Kyle. You're annoying me. Like, no, sometimes I switch to cats, but no, never taking away dogs. Traveling 24/7, as you know, Cincinnati. That was my last beautiful stop. Great city. And then please send your food suggestions. Hashtag send me those foods, because I am always hungry, including right now. I wish I had more than just a piece of bread before I started this. Okay, how is this gonna work? Guys, this is unit 2, you know the drill, but we're just gonna go over everything just to make sure, because I already have these slides prepared and just wanna go over them anyway. Ooh, lecture questions. Lecture questions should always be in the lecture questions channel, please. Let me actually go down here. Wow, people have been talking in this. Oh yeah, it's because I didn't teach that last one. Oh, I know I didn't. Oh, I didn't teach that last thing. This isn't today, was it? It is today. Subtitles not on? Oh no. I said my transcript. Give me a second here. Give me 1 second. Stop share. Why are you not working? 1 second. It doesn't let me do. There we go. Enable live. There we go. Okay, that was weird. It was not letting me see that option. Oh, you ruined my flow. There we go. All right. Lecture questions. Please put all of your questions in the lecture questions. And there we go. Participants goes up there. Perfect. All right. And no Zoom chat, please. But I think it's already disabled, so that's just a moot point. And I'm glitching out again. All right, continuing on. Don't forget, we have lecture slides. If you guys just love seeing my lecture slides and wondering, like, how can I be more like Kyle and teach that? Again, it's all about me tonight. Lecture slides are always on the Google Drive. That is the link for it, but I will send it all again. Amy, there's not actually a test. I promise. I'm not that vain. Okay, so is everybody ready for a sweet surprise? Yes, you went through my entire spiel. The surprise is that I have more stuff for you in this unit. Woo! Yay! Air horn, whatever that thing is. It's going to be on YouTube. What we're going to have with this one is the lectures. As always, these live lectures that we're recording right now are going to be on YouTube. Also, excuse me, exercises. So you have made it to Unit 2, therefore I'm going to reward you with the exercise videos. So all the exercise reviews are going to be on there. You should already see the first one in my channel. And then also the studio videos. The downside about this unit is that, not really downside, but we're going to have studio videos too. So at 8:15, 8:30, a studio review will be out also for you to go through and double check your studio. There will be a few live ones during this, but most of them will be through the videos. That leads me to, okay, Kyle, when do I get to chat with you? Well, great question. It was one-on-one meetings with Calendly. So if you need to chat with me, you want to talk about the studios, you want to talk about the exercises, book time with me, do one-on-ones. Jay, just keep those notes, are always going to be great. But one-on-one times if you want to talk about anything with that. So the lectures, the studios, and the exercises, those will all be videos available to you all. Fair warning, my first videos on there I go a little fast, mainly because they're supposed to be a review. So you should already have it done by the time you're watching that video. But I do apologize. As you already know, I talk a little fast. And that one, it's edited, so it sounds like I'm basically the fastest talker on the planet. So I apologize in advance. You can still yell at me, I get it, but I am apologizing now. Okay, take a deep breath. And I ask you now questions. Any questions? To answer it, no, there's not actually a quiz. But any questions? Taco Cat will be on his quiz. Oh, Taco Cat will definitely be on the quiz. Anything else? Okay. And apparently I was really scared that people weren't going to ask questions on my last unit. So I was like, please, please, please ask questions that no one has asked. Can you post the link for the YouTube channel? I can. If there's any TA or TF out there that has it on hand, feel free to post that. But I'll post all that information here after lecture. To also give you all a little bit of a heads up. Sweet, thank you. I have no idea why it's K Dan Fire. I think it was a child when I made that. Regan, we will definitely talk about that. So real quick, also, these lectures are going to be going till 7 now. So I know I don't get to spend any time with Studio Review with you. Therefore, I'm going to make it up by talking your ear off even longer. Isn't that great? So just FYI, this is going to be going to around 7, 6:45, 7. That's usually when it needs to end, just because there's a little bit more to go through. All right, everyone, welcome to Unit 2. And right off the bat, to answer your questions, there are 4 graded assignments in this guy. So we are going to have 4, which is not 6, isn't that nice? But twist, we have one Studio 19, that will also be graded. So it's going to be 4 graded assignments, and the final Studio 19, will also be graded. All of these have to be completed in order for you to graduate this course. In this course also, Java will be the main language. So unfortunately, yes, we are learning JavaScript and HTML over there, which those aren't all the way gone yet. But just know that from all of that, those concepts are going to be coming into our current unit. So remember that all those concepts are not going anywhere. That's it, everybody. That's my spiel. Welcome to Java. So any final questions before we hop into this bear of a topic? Get it? Because bear.
Not seeing attendance things. Are those gonna pop up or is that not?
They will definitely pop up. Attendance is still mandatory. Yeah.
Okay.
Just like Unit 1.
I figured they were gonna do the same thing, but
yeah, you should definitely see that. Greg will probably be on that. But yeah, attendance is still mandatory. Yeah, I don't know. I think they have the keyword or the password or something like that, which is new. So there'll be a question for Greg too if anybody else wants to talk about that, which he'll be on at the very end. Any other questions? Great question. All right. You ready for this? Everyone's like, Kyle, just calm it down, please. It's Thursday. I just got back from work. I don't want to deal with this. But the reality is I just can't wait to talk about Java. Has anybody out there asked themselves yet, let me see. Oh, I see a question. I'm going to calm it down. Take one more sip of water before we do this. Timothy, I see you typing a question. Do you just want to say it to me, or you can finish typing it? You've already created it.
It was kind of a question that I was going to ask once it was a little bit farther in, because it's kind of technical. Cool.
Sounds good. Well, then, great transition. Let's get technical. Today, we're going to be talking about Java, but you probably already asked yourself, who or what is Java, and what in... Oh, I forgot I have this on timer. God, I was so fancy with these other ones. And what does it want? So that was funny. So we're going to be talking about Java all day today. So, but before we do that, let's go back to our best old friend, JavaScript. Everybody remember this? Wasn't that the good old days, right? Everyone's like, yeah, I miss variables. How about this? Remember this? My little function, right? Isn't this great? It's like, okay, I'm feeling comfortable. There's like a little warm feeling inside, like, I missed you, JavaScript. Now, remember, we have our variables, and then this thing down here, we call it a function. So my function, obviously, I named this a little bit descriptive here. And then finally, we learned one final thing here, my class, which my class, that capital M, it's always capitalized. So this is all JavaScript. This should look like nothing new. So what happens if I wanted to create an instance of this my class? Again, this is nothing new. We've seen all this. It's down here. Let my class equals my class. We created an instance of this class, and then we call to the my function. Now, who can tell me what the output of this is going to be? looking at our code here, get those gears going. What is going to be our output here?
Our variable is dog.
That's going to be one of them, but we have two console outputs, it looks like, in that function. What's going to be the first one?
My param is cat.
Very good. My param is cat, and my variable is dog. That is exactly right. Awesome, awesome. So this is JavaScript. Again, it should be fairly recognizable. It's only been a week and a half-ish, so we should be able to recognize most of this. So the fun thing that I wanted to bring up today is that we're not moving that far away. Let's bring back that variable that we just saw here. For JavaScript, we're going to be moving into Java, the Java land. So we're going to take a look at a variable for Java. This is what it looks like. These two are exactly equal. But as we can see here, kind of how we saw it in TypeScript, we're denoting what the actual data type is here for my variable. Remember, string is a data type. So on the top, we see JavaScript, where we used lets to start creating our variables. And on the bottom, we see Java, where we are starting to create our variables using the data type that the variable should be. So what exactly is going on with this? What are they thinking? So let's take a look at this JavaScript again. And now we're going to take a look at Java. Again, these two variables are exactly the same. They do the exact same thing. They're both strings. They both hold dog in them. But we're going to bring a few more in here. Let's go ahead and bring in maybe the number 10. Now look at the right-hand side. We see that, or I'm sorry, on the left-hand side, we say let my variable 2 equal 10. But on the right-hand side, we say int my variable 2 equals 10. So look again at Java. We're denoting those data types as we move down. Now, why do we exactly do this? Why does JavaScript not make us do this, but Java does? And the thing is because there are two different types of languages. On the left-hand side for JavaScript, it's going to basically dynamically figure out what kind of data type that variable should be at runtime. When you press start on that application, it's going to figure out what data type you're wanting to do. So it's going to be like, okay, I see dog in quotes. You want a string for my variable. Then it's going to go down and see number 10. It's like, okay, number 10, that's a number. Let's slap number on that. I got this for you, Kyle. That's awesome. Do whatever you want. You're being awesome. It's all cool on JavaScript. This is what we call dynamically typed. It's dynamically figuring out what your data type is as you move down or as you compile on runtime. JavaScript or Java is a little bit more strict. Java, on the other hand, and hold on to that question. It's not showing me who it was. I'm not being anonymous now, but hold on to that question and I will get to that. Java is a little bit more strict. Remember in TypeScript, it was our policer. Java is a built-in policeman. It's like, no. You need to tell me what this variable is supposed to be right now. I'm not going to figure out anything. I'm lazy. This is what we call statically typed. Statically typed, you absolutely tell them straight up, right then and there, what the data type should be for that variable. This is the difference between the two. So any questions about what we just covered with dynamically typed and statically typed JavaScript and Java before we dive a little bit more into variables? All right, still got everybody? All right, let's keep going then. Let's talk about the data types of Java. We already had one today. We have dog. Dog is a string. We denote it with string there. Let's move on a little bit more. We just have K here, K for Kyle. But as we can see, that this is a little different. Take a very close look at this char for K and dog. Look very, very closely at these things. Dog is wrapped in double quotes, while K is wrapped in a single quote. Now in Java, if we want to create a string, we must wrap it in double quotes. If we want to create a character, a char, we have to do it in single quotes. That is very, very crucial. So always remember that. Characters are in single quotes, while strings are in double quotes. Java will absolutely yell at you. Let's keep moving on. Int my variable equals 10. Int is short for integer. Integer, which is just another name for a simple number, basically a whole number, and also negative numbers as well. Let's keep looking at this. Let's get a little bit more fancy on our numbers. 3.1415. In this one specifically, it is a decimal. So we actually put a double in there. Double just means that it's going to be a large number with possibly some decimals in it. And then finally, we have another one, float. My variable float, 3.1415. This is another way to denote that this number might have a decimal in it. It's going to be a larger number. Absolutely right, Trey. That is definitely some good pie. All right. So take a very close look at these names. You have string, char, int, double, float. But can you see the difference between string and all the other data types below it? Look very closely. Character, int, double, and float all have lowercase letters, while string is uppercased. What makes string so special? Well, char and all these other ones down here have to be lowercase. The reason being is that the ones that are lowercase are called primitives. Primitives. This is where, or this is the atoms, the building blocks of all that is code. Primitives are the lowest thing you can go. Basically, everything is made from a primitive. Things that are made from a primitive that is also a variable type is called a non-primitive. String is a non-primitive. So lowercase means primitive, while uppercase means non-primitive. So before we keep diving into this, let's talk a little bit about this non-primitive here. I've already mentioned it, but this non-primitive string is made up of primitives. What do I exactly mean by that? Let's look at dog, D-O-G. D-O-G is made up of 3 characters, chars. Chars are primitives because, as you saw, C is lowercased. So this D-O-G, these 3 characters are put together to make a string, which is a non-primitive. Again, that non-primitive is made up of primitives. Did I have an F after that? No. You do not need an F after that number. I mean, there might be a reason why it's denoted that way, Malin, to answer your question, but no, you don't need to do that because float in the very beginning will tell Java that it is supposed to be a float. All right, before I continue here, I got another question. Andrew, can you assign dog as a string to my variable and 25 as a int to my variable, or do they have to be different names? So just like JavaScript in any programming language, your variables always have to be unique. So what you see here, technically, if I put this all in the compiler, would break because my variable has already been created. So to answer your question, no, you are not able to do that. So your variable names have to be unique, as always, just like in JavaScript. So you'd have to do, for your example, string my variable equals dog, and then int my variable 2 equals 10. What is the difference between double and float? That is a very nerdy question. That is a very good question for a nerdy answer. Doubles and floats, like I said, hold large numbers. Numbers can be very large. Just think about how many views a YouTube video can get. Essentially, floats hold 32 bytes of information, while doubles hold 64 bytes of information. So basically, an ints only hold 16 bytes. And I might be, to anybody who knows is actually in the room, I might be throwing that off. But essentially, ints, floats, and doubles all hold different large values of numbers, while floats and doubles can only have decimals in it. All right, so Ryan's question, aren't the characters in dog only characters because they are wrapped in quotes, for example, if you were? Technically, yes. If you wrote in quotes 1, 2, 3, 1, 2, and 3 are all characters or made up of those characters, the primitives, Ryan. So yes, you are absolutely correct. And then Jason, if you were redefining a variable, would you need the primitive / non-primitive data type? No, if you're redefining a variable, it's just like redefining it in JavaScript. You will just say my variable equals cat. So yep, that is how you redefine something. And bring that back. There we go. Awesome questions, everybody. So like we said, non-primitives are made up of primitives. So let's keep diving into that concept. I'm going to blow your mind a little bit even more. Character char, my variable equals k, and character with a capital C, my variable equals k. These are 2 valid lines of code. Everything is okay, but we see that I need to get my power cord. We see that C is capitalized. So when it comes to that, we know that this character is technically a non-primitive, but let's dive a little bit more into that concept here. We know that char is a primitive because it's lowercase c, while our C here is technically non-primitive, but has a very specific name. And that specific name is called a box. We're gonna talk about boxing here. I'm gonna give everyone here a quick second break for me chit-chatting because I need to get my charger, and I apologize for the intermission here. Gosh, how needs to pull it together? And it's going to be on the recording, right? Any questions so far what we're talking about? Anybody want to shout them out? Well, I am getting essential power to my computer. Anything at all? All right. If not, I got power. Let's keep going then. So you might have seen in your reading a thing called box. Like we said, C is a non-primitive. It's made up of primitives, but it's called boxing. So let's draw a box and talk about it. A box, or this capital C character, is basically a primitive inside of it, but it has something special to help us out with. The character, the capital C, this character data type that has that capital C, wraps our primitive of the character, but inside of it, we have something inside of this box to help us. We have helpful methods, like is letter or is number. We have helpful methods inside of that box to help us out when dealing with characters. So when you hear a box or you see this capital C on there, not only do we have a value trapped inside of this data type here, but you also have methods to help you out with things. So that is what the difference is between capital C and a lowercase c in your character. So tonight when you're in IntelliJ and you see a capital C, do, for an example, my character dot is letter, or my character dot to string, or something like that, and you'll see these methods are there to help you out in certain times of need. So, like I said, in, there we go. Like I said, character dot is letter, and then in the single quotes, whatever you want to do exactly. So it will, this one specifically, because I can't see because the transcripts are over it, but we'll put back false, I believe. I put 1 in there. So is letter would return false because 1 is technically not a letter. All right, enough of me chit-chatting. We're going to talk about this. What types should these be? Yell them out to me. What should 100 be? What kind of data type?
Int.
Int. Very good. Absolutely right. How about this guy?
Char.
Char. Very good. Char. This is only a single character. Technically, you could have told me string, but I want to go with char here. How about this one?
Double. Float.
I like both of those. That's absolutely fine. Yeah, float or a double, either one you want to do. I believe typically in the assignments they use doubles just for everyone's note taking. And then finally, our favorite word of the day, pizza.
String.
Right.
Very good. String. And remember, what is the difference when we're denoting characters and string? What do we use with characters? What do we use with strings?
Strings, you got double quotes.
Oh,
Very good. Absolutely right.
Quotes.
Yep. Characters have single quotes. Strings have double quotes. Last one. How about this guy?
Char.
Technically, a string.
Eh?
How?
It'll also be a character.
Oh.
Remember, characters are anything. Spaces are characters. Exclamation points are characters. Hashtags are characters. Anything that you can think of as a character. But only one of them. You cannot put 2 characters next to each other and try to call that a character. You will break Java. So that is not allowed.
So why do you say technically a string, if you don't mind me asking?
So technically, a character can be a string, but a string cannot always be a character.
Okay.
So basically what I can say is that I can put double quotes around this A and change char to string, and nothing blows up because it's a single character inside of my string. But if I try to make dog into a character, I'll get yelled at. So that's what I mean by we can go one way, but not always the other. We can go from char to string, but not always from string to char.
I have a question. So why is white space char when it's like nothing there? Because then they say that in the book, like just a space or something.
Yeah. And like I said, anything on your keyboard can be a character. The space button right there, that's a character. Emojis are technically characters. You can also do Unicode.
What if it has, what if it's something with like umlauts or something? Like a U with umlauts in German or a Greek letter?
Literally anything from any language, even Chinese characters are technically on the ASCII chart. So yes, that is also a character. So if you are interested in seeing exactly all the characters out there that you didn't even know existed, look up ASCII, A-S-C-I-I. That ASCII table will bring back just things that you never even knew were out there. And for some reason, developers made them. But there's a lot of characters out there, not just what we see on our keyboards. Awesome questions, everybody. Any final questions before we move on?
So you're saying with char, it wouldn't get mad if you used double quotes, just vice versa, it would get mad if you use single.
So if you use double quotes, you have to change the data type to string.
Okay.
I have a question.
Yeah,
What do you know of a way that you can create your own font?
That's not really in the context of this class, and I actually have no idea about creating your own fonts. Yeah, I apologize for that one. I have nowhere to help.
If anyone knows, can they send me a message on Slack, please?
All right, we're going to continue on here. So
Okay.
for these data types, basically that's what we're looking at. We're looking at mainly our ints, chars, double strings. That's what I'm going to be hammering in today. So let's keep looking at another classic though. What are we getting into this time? We are getting into things that you've already seen. Again, we've seen that class, my class, and then those open and close curly brackets. So this is JavaScript. Take a look at it in Java. It's going to be super crazy. Look at that. It's exactly the same, but we use one new word here, and this word is public. Let's talk about what exactly public is. Sharing is caring. So we're going to talk about what public here. So we have this Java public class. Remember, in classes, M or the start of all classes are always capital. Always, always capital. Java loves classes. So classes are not going anywhere. Everything in Java, if you haven't seen already from if you worked a little bit ahead, everything is a class in Java. So let's talk about what we are exactly talking about when you see public here. Say if I want to create an instance of my class. Well, absolutely. You can definitely create an instance of my class that we just built here because it's public. We use that keyword public. But let's look inside of my class. We see private string my var. Now, if this thing, whoever's asking, asks me that can I get the value of my var, we say no, you can't. It's private. So who's exactly talking? The people who are talking are other classes. Say you make a public class my class 2. My class 2 would ask for my var and it would say no, it's private. We're not trying to share information between classes. So that's what these keywords are doing. And they're very, very important in classes because it shows what exactly, what data and what methods can be used throughout our Java applications. And so pay very close attention to where you use public and private. To answer your questions off the bat, or just to give a little bit more clarity, classes are typically always public, while class variables, such as my var, are typically always private. So classes are always public, most of the time, of course, 99%. And then variables, my var, or class variables, are technically or typically private. Ryan, to answer your question, I would have to dig a little bit more into that, but it doesn't extend scope. It just allows access to that specific part of the scope. So hopefully that gives you, the question was, so does public sort of act like a global as far as extending scope? And it does not extend scope. It simply just allows access to it. Yes, if you don't type private there, I believe by default, and I always get this mixed up, but by default it is private. So, but make sure you're always denoting them. But by default, yes, everything is, I think, set to private. This is a tricky one too, and this rules most of Java. So any questions also about this? Anything out there? See one more person
Can you
typing.
say public
Yeah.
string?
You could say public string. You could say public string my var, and that would just then allow anyone out there to access your var. Now, sometimes I get this question is, okay, why would I even want to create something private inside of my classes? What's the even point of that? And the fact being is that, say you created maybe a debit card class, and you use this debit card class to pay for things. So you say, my debit card dot pay bill. That's fine, but think of also what's also in your debit card. Maybe you have a string my PIN inside of there. Do you want other classes knowing about your PIN? Or do you just want them to allow you to charge for bills? The answer is you don't want them to allow you to do the PIN, so you set your PIN to private. Well, you allow the method pay my bill to be public, and then that method would use that PIN. So essentially, you don't want always have to share all the information. Sharing is not always caring. So that is what I was trying to get at with that. Now I have several people typing. So I have started a frenzy here. Okay, what about, yeah, go ahead, Jen.
So that means it wouldn't make sense to say private class, my class, public string. That wouldn't make any sense, right?
Well, yeah, it wouldn't be necessary to even put public string because we couldn't access anything inside of that class.
Yeah, okay, I was like, okay.
Exactly, so that's why we never make our classes private, because then no one can use them. What about nesting a public class inside of a private class, or is that another thing? We do not nest classes inside of classes. That is, well, oh, that's not, yeah. We cannot do that in Java or JavaScript. Yes, we will be getting into that here in a second. So in the debit card example, could we still check against the private string to see if it's equal to a user's input, how the password works? Yes, so if you are inside of this my class, you still have access to my bar. If I created a method below private string my bar, you would have access to it because you're inside of that class. So great question. We're gonna dive a little bit deeper into this because I think if we keep going down this lecture, a lot of these questions will be answered. Cody, yeah, absolutely. I mean, there's a lot of authorization apps out there that are built in Java or these kinds of languages. So yeah, you can definitely do it that way. All right, let's talk about classes and objects here. I can't even read that. All right, so like I said, Java loves classes. Anything and everything will always be wrapped in a class in Java. And you'll see that the second you open up a new Java application in IntelliJ. So let's bring back that class we were talking about, public class, my class. And then let's go ahead and just bring in another class here for our sanity's sake. We have my other class, an object of my other class here. So I create a new instance. So I say private my class equals, oh, I didn't even put, for some reason I had a ton of typos in here. It should be private my class and then our variable name, which will say my class, lowercase m, equals new my class. So we're just building an instance there. So why we do this is, and why is everything wrapped in a class, is because Java is what we call an object-oriented programming language. It means everything inside of a Java application is an object. And again, where do objects come from? They're instances from classes. That's why Java is called object-oriented and everything's wrapped in a class, because in order to be object-oriented, everything needs to be an object. Therefore, we need classes to do so. So this right here is an example of how we can use classes to build objects and utilize all that information and methods inside of a Java application. So any questions on this? Otherwise, we get to hop into true or false. Help me out here. Just make sure everyone's still on the same page. Class variables should always be private. True or false?
False.
False.
Oh,
That one is true. Class variables should be private. Class variables are private. And then what's public?
Class name.
Classes. Class is public, variables private. Class is public, variables private. Let's keep going. Private variables can still be accessed within their own class. True or false?
Yes, true.
True.
Very good. That one is true. Yes. If I'm inside of that class and something is private inside that class, I can still get access to it using that this keyword we saw in JavaScript. All classes ever should be written in a single file within the application. Ooh, we didn't even talk about this one, Kyle. That is false. Absolutely. Every class should have its own file. That's a tricky one too, because like, how did you even talk about that? I was like, you're right. Well, we should have. So yes, every single class, when you build a new class, that class is gonna have a new file. So that is it. That is like period. That is law in Java. All right, let's keep moving on. Like I said, I promise we're not moving that far away from JavaScript. So let's bring in that function that we did here. My function. So we have this console log, my param is my param, and then we have the variable. Let's go ahead and translate that into Java. If we translate that into Java, we're gonna be looking at something like this. So let's take a look at a couple things here that we're now starting to see. First things first, take a look at this void and take a close look at this string. What in the heck are these things? There, cool. What in the heck are these things going on? So looking at this, let's go and explore a little bit more about it. So bringing that function back, or bringing this method back in. Also, side note, if you're noticing that I'm calling these methods now, in Java, they're referred to as methods. In JavaScript, they're referred to as functions. So I have to, when I switch over my languages, I have to talk in how they're referred to as. Otherwise, I get snubbed at the nerd conferences. So yes, methods is the new term for functions. Is there anything different? Not at all. They're exactly synonymous. But someone just thought that would be funny to change names up. So yes, methods. All right, let's talk about these things. We've circled void and string here. Let's first talk about void. Void is a black hole. It is nothing, meaning that nothing is going to be returned from this method. So even nothing is something in Java. So if your method is not going to return anything, the return type is void. So every method inside of Java is going to have a return type. And it's also, every method in Java will have a return type on it. So that's what void is there. It is your return type. If it's not going to return anything, it's going to be void. Talk about it a little bit more. If we look at this particular example, we see that it's going to return a string. Therefore, I denote that it's returning a string by saying public string my return method. So this is where our return type goes. So any questions about return types before we dive a little bit deeper into other things? Remember, every one of your methods has to have a return type. I'm getting some puzzling looks like.
I'm looking at public string, my return method. And why does it say string in front of, why does it say string there? If it's, because you wanted to return a string.
Exactly right.
Never mind.
Very good. Yes. I'm happy you're calling it out. So yes, we say public string because string is the return type to everyone else out there, and then the name of our function or name of our method. So yes, that is what this line is doing. And then we return hello world in those quotes, double quotes to be exact.
In what instance would we be using a void function like that?
Exactly what we see in the very top. If it just does something like print something out to the console and doesn't need to return anything, we just say void. There's a few. Go ahead.
Is void for like if you're not returning anything, but you're going to use that parameter or whatever it returns in another function?
No, void is for if it doesn't return anything, nada, nothing at all, zilch. So as we can see, I didn't even put a return here on this my function because it doesn't return anything. So void is if it just doesn't return anything. Now, if you just call to another function inside of my function, the one we see above, when you say you call to my return method and you do stuff with those, what's passed back from that one inside this function, that's absolutely fine. It's just that void is just denoting that my function will not return anything back from it. And we'll see more of this in an example. Just keep this in your head as we move forward. But just remember, if it doesn't return anything, you put void there. V-O-I-D. Any final questions?
Is that the only return type that needs to be lowercase compared to strings return type as uppercase?
So we see that string is a data type. We put a return type, AKA a data type. So void is a primitive. So that's why it's lowercase. Very good question. I know I love this because we're talking it out. No, I'm A-okay with all these questions. This is awesome. All right. Told you I missed you guys. Okay, let's keep going. I mean, where else can I just talk about code for an hour and a half straight with people besides every day at my job? All right, public void my function. And then let's take a little bit closer look at this other thing over here, this string. Now you kind of already saw what we're doing here in TypeScript. But what we want to really call out here is that Java needs to know your parameter data types. Always, always, always needs to put the data type before it. You need to do this to tell Java exactly what you're going to be passing into this parameter. So I'm just in this example, I'd say string. If I wanted to pass a number in, I'd put int or double. But whatever I want to pass in there, I have to put it inside of those parentheses. Just like JavaScript too, if you want to pass in 2, 3, 4 million parameters, you just just separate them by commas. So that is that. Any questions about that? All right, we're learning all this stuff, but we still haven't seen IntelliJ. And I know, we're gonna do that. We have to learn one more thing before we're able to go over to IntelliJ. So let's go back and, oh no, I keep doing that every time. Remember this exercise, this JavaScript class, my class, let my variable. Anyone missing JavaScript right now? My function, my param, all this stuff inside of this class. You now have the know-how to translate this over to Java. That being public class, my class, private string, my variable equals dog, then public void, my function, passing in, oh no, I need to go back through and correct these. Kyle, 2020 Kyle is making mistakes left and right when he built this. But as we see, I already have an issue here. It should be string my param in those parentheses because I have to denote the data type, exactly what we just talked about. But essentially, this is how we would translate it into Java. So any questions about this? And no calling out all of my mistakes. Can't be mean to me on my first day back. All right, I got system.out.print returns to the console, right? So where would return to? So remember, return something back from that function. The system.out.print line, which is basically the same thing as console log, shows the user something. Return returns back to more code. System.out.print line returns to the user. So that is the difference. So return would return back to wherever I'm calling this function from.
Hey, Kyle, question for you. So when you're using like this public void function, is it really just something where you're planning on just storing information and not ever returning the information? It's just storage only?
So it could be storage, but remember fetch. If you want to do maybe some kind of process in here or something like that, something that you don't need to return data out for, you would do it in a void function. I'm trying to think of a good example here. We'll talk about references in the future, but essentially just think of a void function as one that's doing a process within itself, and it doesn't need to tell anybody about the result. So it's kind of a very selfish function. It's going to do something, it's going to find some information, but it's going to keep it all to itself. Or like how we see in this example, it's going to present information to the user in some way. So there will be times, and void functions are not rare. So there will be cases that you'll see this. But I would say hold on and see more examples before I guess we can really come up with a good example for void. But yeah, sorry, Jason, that was a very, very ambiguous answer. Does that help out a little bit?
Yeah, it helped out a little bit. Thank you so much.
Yeah, absolutely. All right. From this example, though, we should also note that these concepts that we learned in Unit 1, like I said, are not going anywhere. They are staying exactly how we see this. All right, so let's finish this up. Help me out here. My method's return type is blank, therefore it doesn't return anything.
Void.
Void, yes. That has been the topic here. So yes, void is the correct one. Classes are public and class variables are
Private.
Very good, private. And then finally, my variable value is going to be a name. So I'm going to make my data type a
String.
How do I spell it? With a capital or
Capital
S?
S.
There we go. Awesome
Double quote.
job. Air high five. And double quotes. Yes, extra brownie points there. Fantastic. All right, the final thing we have to learn today, folks, is the starting point. As we already know with JavaScript, how we ran it is that it just went to this file that we told it to and it ran. That's not how Java works. Java always needs a starting point. It needs to know where to run its application from. And there is only one way to make it, and there is only one starting point that you can create or start from at all times. So like I said, every application needs a starting point. Every Java application needs a starting point. Java needs the starting point called a main method. And someone already asked this question previously. This is the code that denotes a starting point in our Java application. Public static void main string, and those brackets there, args, and then the code goes there, whatever I want to do. Now, like I said, everything always is in a class. So we typically put this code, or we always put this code inside of a class. So we say public class, my class, and we wrap that name method. Now look at this very, very specifically. First things first, we see that it's static. Let's talk about what static actually is in Java. So say we bring back that dog class that we were talking about. And I have 3 dog objects. So we have, of course, I got to bring in a dog example here. We have maybe Buddy, Frodo, Shiloh of age 7, 3, and 4. So we have 3 different dogs instances from this dog class that we were talking about. So if I have the animal type mammal in this class, there has to be a way that I can maybe share, or sorry, we see that the animal type mammal is equivalent to every single instance of that dog. So we have Buddy, we have Frodo, and Shiloh. Those are all different names, all different ages. Those names and ages are dynamic or specific to those specific dogs. But the animal type mammal can never change. Every dog, all the time, no matter what it does, will always be a mammal. When we want to share information like that, that cannot change, that is consistent across all instances. So again, information that cannot change and is information that is equivalent to every instance that will always ever be created for any object, like this dog, we use static. Static is a way to denote that something will, technically it can change, but it is equivalent to every single instance. So yes, you can technically, sorry, I apologize for that. You can technically change the value of a static variable, but it should still, again, be something that's equivalent to every single instance of that dog or of that type of class. That's what static means. Yes, Regan, I apologize. Yes, Stark was left out. So when we want to denote that a variable is shared across classes, no matter, or shared across instances, no matter what type of instance is made from it, we make that information static. So static variables and methods do not exist in the instance, but can be referred to it through the class. That's a lot there. Static variables and methods do not exist in the instance, meaning that Buddy technically does not have the value mammal within it, but the dog class does. Now remember, classes are like recipe cards. Well, you use a recipe card to make a cake or something like that, aka that cake being an instance. So you use classes to make instances. Classes in Java can now have information inside of them that can be shared amongst all of their instances. Those are what static variables and static methods are. All right, any questions on that, or just yelling at me for just dropping that one? If not, just all take a deep breath, just relax.
They don't inherit each other? Like how in JavaScript you could do inherit class, the one above it?
So we're not talking about any inheritance right now. Nothing about inheritance at all. This is, and we'll see this here in a second, this is a static variable. And we'll talk more about static as we move on. Don't think it's a very, don't take this topic too seriously right now as we're just getting into Java. It's just letting you know that static exists and this is what it is. In the dog class, you can have static variables and static methods. When you create an instance of Buddy or Frodo, those static things aren't technically inside of that instance, they're inside of the class. However, they're still accessible to the instance. So just think of it, I'm trying to think of a good analogy, but just think of it as, like I said, the class is like a recipe card. Well, the cake is what comes from it. That's the instance. Just think of the recipe card has certain little notes on it, and then you can refer back to it while making your cake kind of thing. I'm trying to think of a good analogy for it. But again, don't get too absorbed in the static, but just know it's there and know that this information, these variables and methods do not exist actually in the instance. So they're not opposite of static. Everything else that we've done is technically an opposite of static. Instances are the opposite of static. They're dynamic. So Buddy's name could change, or the age of 7. I'm bugging out. There we go. So the opposite of static is dynamic, and that's how we can create 3 different instances of dogs with 3 different names. So that is, yeah, absolutely. So public is the opposite of private, while instances are the opposite of static information. Yeah, exactly. You just don't have to type something else. That's a way of kind of looking at it.
So you don't have to do like dynamic animal type. It's just static.
Right, yes. And by when we say dynamic, yeah, there's no keyword dynamic, but yeah, you'd say, yep, static. Absolutely right. Okay, let's take a deep breath. We're all good. All good. We're in this together. We're gonna pull through it. All good here. Real quick, we're going to, what time it is? Yeah, I need to get going on that. So let's go ahead and we're gonna finally go into IntelliJ. Let's go ahead and do that. So if you have IntelliJ loaded, feel free to load it with me. So we now have all of the pieces that we need to actually build an application. So that's what we're gonna do here. So when I open up IntelliJ, of course, I'm on a Mac as always. What I'm gonna do is I'm gonna click New Project. Let it finally go. Computers are like working overtime over here. There we go. New project, I'm gonna click on Java, and then I'm gonna click Next. I click Next. I'm gonna just call it Lecture 1. And then press Finish. And then IntelliJ is gonna take probably all of its time that it ever wants, because IntelliJ can be somewhat slow sometimes. There we go. I'll put you right there. Awesome. And let it go. Okay, so this is IntelliJ. IntelliJ is a very, honestly, I use it every day at work, is a very popular tool to develop Java applications in, and also other applications too. You can also do JavaScript in here. But for this one in particular, we're always gonna be focusing on Java. What I just did is I clicked on project over here on the left-hand side. It's gonna be loading. And then I'm gonna go ahead and we see Lecture 1, external libraries, scratches, and consoles. We don't ever need to worry about external libraries or the scratches and consoles. We need to worry about Lecture 1. We go in here and we see an idea folder, which is just for IntelliJ. It's the IntelliJ specific folder. We don't need to worry about that either. What we do need to worry about is this source here. This is called a package inside of our Java application. Like I said, everything is in classes in Java, but what is inside everything that contains classes is called a package. And that's what we're gonna build here. We see that it's blue. So when you are creating a new directory, you need to create packages. So inside of my source folder, I'm gonna right click, say new, and then it's gonna say right here, package. Make sure you do package, not a folder. You know it's a package because it's gonna have a dot in it. So what I'm gonna do is my package names are usually lowercase. So I'm gonna say first application. There we go. And as we see here, we have their little folder directory, but we have a dot inside of it, which denotes a package. Finally, we're gonna right click, say new. Let's say new Java class. This is where everything begins. So it's gonna make sure class is selected. And now I'm gonna say first class. Press enter. And there we go. Now, welcome to Java. This is exactly what a Java application should look like. We always start inside of our class. As we see that IntelliJ already created a class for us, so that was really nice. Now we actually need to begin by creating our starting point. Can anybody refer to me what that starting point is again, by any chance?
Public static void.
Private.
It's actually public. Got that. So it's public static void. And it has to be exactly typed, just like this. And I'll keep going. It's going to be main string with a capital S, and open and close square brackets, and then ARGS.
Args.
Args, yes. And we haven't covered it yet, but in case anyone's wondering, this is for an array. We want to build an array. We haven't talked about it yet, but we'll see that in the future. That's for arrays there. All right. Welcome to Java. That's it. Who can tell me what the equivalent of console.log is for Java?
System dot.
System
print line.
Yeah.
Hello world. And we see that I'm already getting a red line here. That's because semicolons are always necessary in Java. It will not compile without that. Like I said, Java is kind of strict now. So what we need to see here is that we see 2 green arrows. We see one at the public class, first class, and then one at this public static void. You can click either to start running. I'm just gonna do this one just so I know. Do that, and we're gonna let that run. It's gonna compile first, and I believe a terminal should pop up below, unless I absolutely broke my. There we go. All right. As we can see, we have this blue line here. That's just a little console output. Nothing to worry about that. Just tells me what my JDK is. Now we see hello world. Awesome. We just successfully ran our first project. So any questions about how we just did that, what this starting point is, or anything about IntelliJ that you all would like to see?
So how did you, I'm sorry.
I was gonna ask, so the public static void main, is that just something we were doing for this specific example, or is that the standard we always have that?
This is the absolute standard. It is crucial that it's typed exactly like we just did.
Okay.
Yep, very good question.
So where would you
Java
put the private variables? Where would you put that?
Very good question. Up here is where we would do that. So up here we do class variables. So here we'd say private string my var equals pizza. And then if I want to come down here, I'd say plus my, let's say this dot my var, just like that. Save that. Oh, I forgot.
I can't get the one software to open.
If you're talking about IntelliJ, ask your TATF. I can't help you right now, any individuals, but ask your TA to help you out and get that software going. I apologize. I cannot access my var because it is a class variable for the instance. As we see that it's not static. So if I try to do this, I say plus this dot my var, it's not going to work because I'm trying to access this from a static method. Remember, this right here belongs with the instance, with our dogs. This right here is static, so it's in our classes. They're in 2 different areas, so I can't access it. I wanted to access it, say static. And I wouldn't put this because that is calling to the instance. There we go. So now we're able to do that. We press run again. But to answer your question, up here is where those private variables would go. I got a question of how to run the program. So you should see a green icon here to the left of your main method. You click on that, it should compile, and then we'll run that method. You'll also see one up here. Either one you click is absolutely fine. And now we see hello world pizza.
So if you click the green arrow, does it only run the portion until the next green arrow, or does it run the whole thing?
So remember, we're only going to have one starting point. So if you click this one, actually, that's a good question. Let's see if we have 2 starting points, see what it does.
Well, see, like you've got a green arrow on 3, 8, and 12 there.
Okay, so I see, you said 3?
Yeah, line 3.
I only see 2 arrows here. So I have one at the class level and one specifically at the main level. So either one will run the same code right there.
Okay, so it does, if you click the one on 8, it doesn't like just start at 8.
No. Either one technically it does start at 8 since that's our starting point. So yes, it will start at right here. This will be the first line of code that it sees. Because we're in a class, so of course compile everything together, but this will be the first line that it sees right here, the system.out print line.
How do you rename, sorry to interrupt you. How do you rename the class name? So the first class, so I had a typo there and I tried to fix it and it's not working.
So what you want to do in that is that you'd right click first class over here, press refactor, and then press rename. Do that, it pops up. First class redo, refactor. As you can see, it renames the class name over here and also up here in our public class. And also we'll go through your entire application and rename it for you too, wherever it might be referred to as.
Nice.
Awesome. All right, everybody, great questions so far. Let's go ahead and do one more here. I'm gonna do new we're going to do Java class. I'm going to say my class, since that has been in our example the whole time. We said my class here, and we said they were going to have a private string my var equals pizza. And then we have a public. And then what do we put here after public for a method? What do we need to do after our public? What's the next thing?
Public static void main.
So that would be for a starting point. Here we're just going to create a method. In a method, we have to do the accessor, which is public. And then what comes next right after the accessor?
Static.
Return type.
The return.
The return type. Very good. In this case, I'm going to just say I'm going to return a string. And I'm going to say my method. And what I'm going to do, I don't know, I'm going to just take in a string, my string, and I'm just going to add an exclamation point to it. So here we go. We see we get an error here. This error is saying that we're missing return statement because I promised it up here. So I'm going to say return. I'm going to say my string. And then I'm going to add just a few exclamation points behind that, just like that. Save. There we go. We've created my class. So let's go back over here. And what we're going to do is that we're going to run it inside of our starting point here. So what we're going to do up here is that we're going to now create a new instance of my class. Who can talk me through that? How can I create a new instance of my class?
We can create an object.
We would create an object. How would we do that in Java?
Is it my class
Very good.
equals new?
I love it. I love it.
Then again we can
The name.
It'd be my class.
The name my
capital,
class.
just like that. So it'd be new my class and then open and close parentheses, just how we did it on JavaScript. Very good. Then finally we say my class. Now look very closely here. We go back to my class real quick and we see that we have my var here. Let's try to get my var out of there. You see, it doesn't let us do that. It says my var has access, private access in my class. So I'm not able to do that. I come over here and I change this to public. Now it's accessible. I'm just not doing anything with it. System.out.println. So now with that, I can actually access it because I changed the accessor. That's what makes this very important. So we should always keep that private though, as always. Just wanted to show you real quick. And then finally, what I want to do is I'm going to take my class and I'm going to call to our only method inside of there. So dot my method. I'm going to pass in dogs. Now, this is going to return me back a string. So I need to catch that. In order to catch something back from a return, I say string, my method it returned. Just like that, just again, creating these ambiguous variable names. Say system.out.println, and then my return method. There we go. Save that, and let's go and run this and see what happens. And also what I just did there, and I apologize for not saying that, instead of clicking here, once I click here once, I can actually come up here and click this green arrow. That just sets our configuration essentially in IntelliJ. But just for everyone else's sake, I'm going to run it from here too. Press run. And now we see in our output, we see dogs, exclamation point, exclamation point, exclamation point. So that is how we can create a new instance of a class in Java, call to one of our public methods, and then output that return to the actual screen. And that is an example of IntelliJ. So any other questions about that?
Do you have to import, export in IntelliJ if you were going between packages, maybe?
Technically you would have to import, export if you're going between packages, yes. If I'm in a different package, I'm gonna have to import it from that package. Great question.
Mm-hmm.
Yeah, very, very good question.
Okay,
We know
Kyle,
we
I
have
a
to,
question.
yeah, please.
When I was working on the exercises, I had several of these classes open, and I had half finished, like let's say you've got two there, first class redo and my class. So let's say I had half finished my class and I wanted to kind of remind myself how something worked in the first one I had done. So I tried running it, but because my class was half finished, it wouldn't actually run, even though I wasn't trying to run that program. So I got confused. Was it because like everything in the package has to be right before it runs any class?
Your job application is a whole. It is one thing. That's what the compiler.
Okay.
That's what the compiler looks at. It looks at a single application, your job application. So if there's an error anywhere in your application, it will not finish compiling.
I see. Okay, I'm used to VS Code where, you know, every file you've got up can be a self-contained thing.
And that's the beauty of JavaScript, but the stickler of Java. Java will make sure that everything is typed and everything is, all the T's and I's are dotted and crossed before it runs. So
okay,
that
so if I want to be running separate things just to learn, I need to have them in different packages.
No, you'd have. So what I would recommend, even in different packages, it will still not. If I have a different package and there's an error there, it will still catch it. Remember, everything in this Java project, the compiler looks at it in the project. Yes. So what I would recommend is commenting it out. So if you want to keep something on, comment it out. That should help you out.
Okay.
Is that why you use IntelliJ and not VS Code for Java?
Either one, because no matter how you compile it, the Java compiler, how Java is structured, it has to look at your entire project at one time. Unlike JavaScript, where we chose which files we want to run, and then it told the compiler what files it depended on. So Java is JavaScript's more loosey-goosey. Well, Java is like, okay, here's the application. This is what I'm going to run. I'm going to run all of it. I don't care what you say. So that's kind of the two different personalities we're dealing with. So even with VS Code, we'd still go through the Java compiler. The Visual Studio Code and what we've seen here on IntelliJ are just the editors before it talks to that compiler. So that would, does that kind of help out, Katie?
Yeah. Is there a reason why you use IntelliJ over VS Code?
Honestly, it's to give the class more insight on different tools. VS Code and IntelliJ are both very widely used tools. So it's good to get just know-how in both of them.
Okay.
But also it's a lot easier to do it in IntelliJ for Java, like a trillion times easier than doing it in VS Code. Cool. Hopefully I sold you on that one. All right. Can you explain the grayed out myString in line 7? Oh, okay. So this is just telling you what this variable is, or what the parameter name is. So you see myString. Everybody see that little myString there? Go over to my class. It is the name of the parameter. It's just trying to help you out. It's IntelliJ being trying to be smart. So myString, hello. So I say that, and I come back over here. Oh, of course. Now we see it updated to myString hello, because it was the name of the parameter. Awesome question. Any other questions out there? Awesome. All right. Last thing we got to go over real quick. Let's keep going. What did what? What contains all of our classes forever and always? Our classes contain all of our code, but what contains our classes? Packages. Very good. Everything, all of our classes need to be inside of packages. Packages. What method is needed to start our application?
Main.
Main. Very good. Absolutely right. That is the only way we can ever start a Java application is through that main method. And then finally, what primitives are strings made up of? Ooh, this is like a whole hour ago.
Chars.
Chars, very good. Every single string is made up of an array of chars. An array of chars, which leads me to my final point. Arrays are back. So you already saw this in that. What was that?
That was being silly. The Eminem thing. Guess who's back? Back again.
Oh, I love it. I love it. Guess who's back? Arrays again. I'm terrible at singing. Okay, arrays are back. And we'll bring in that copy of an array here. Strings, open and close square brackets. This is how we denote a array. And then we have, of course, the name of the variable, my array. Then open and close those square brackets. Buddy, Frodo, Shiloh. Yes, Stark is not there. Stark will be back, though. Don't worry. So if we have this array here created, what does it exactly look like? Well, you've seen this in JavaScript. It's going to open up this little container thing, and it's going to say Buddy, Frodo, Shiloh. So that is how we create an array. We're going to see one more way of creating them. String, open and close square brackets. I'll keep wanting to say curly brackets tonight. Square brackets, my array equals new string, and then 3. This is another way we can do that. And how we would add all of our information, Buddy, Frodo, and Shiloh, is that we would do it like this. Again, you've seen this in JavaScript as well. We'd say my array, square bracket 0 equals Buddy, square bracket 1 for Frodo, and then square bracket 2 for Shiloh. That's how we would do that. Now, one thing I do want to call out, and just a final little note on array, as you know in JavaScript, you can .push anything to array as much as you want. But in Java, you cannot do that. Once you set a specific length of an array, how we see here, it cannot change. You can only have 3 containers inside of an array once you say it's 3. That's it. No way of ever changing it. Like I said, Java is a stickler. So let that be known. If you're asking your question now, like, okay, how can I make something more dynamic? Well, you'll just have to wait for next week. Right? Let's see what I did there. Cliffhangers. Yeah, they're back. Oh, all right, everybody. That is all I got. See, I told you a lot more content, a lot more fun. So we have a few minutes here until 7. So I'll leave it open for any final questions. Anything else you guys want me to talk about here for JavaScript or for Java? Not for JavaScript. Putting that one on the
I have
for
a
a second.
question about the arrays for Java.
Yeah.
Can you have different types of data types within an array in Java? Because it didn't look like it.
To answer your question, no. Like I said, Java's that stickler. You can only do strings. You can only do ints. You can only do chars. You have to have only one specific data type. If you're looking at how, okay, so if you're asking yourself, like, how can you truly do it? Look up the data type called object. We're not going to go into that just yet, but if you are wanting to look ahead or just want to dive a little bit deeper, you can make an array of things called the data type object with a capital O. If you really just want to take your Thursday to the next level.
No, not really, not right now.
Based off of that question, if let's say, for example, if you define a string as 1, 2, 3, then we could actually add 1, 2, 3 in there as a string in the array.
But then to use it as an int, you'd probably have to pull it out and then convert it.
That is true. If you wanted to do that, yes. If you really wanted to work Java over and just say, I told you so I can do this, or just want to do that, yes, you can technically do that, Jason. You can put it in as a string, take it out, convert it back to a number.
Gotcha.
Or an integer in that case.
Okay.
Good question. Yeah, show Java who's boss. Like, no, I'm going to do it. Can't tell me what to do.
Did we show them how to cast stuff from type to type? Or is that come later?
Is this the section? I don't know. You guys want to see that real quick? We got 3 minutes. You guys want to see how to cast things? Sean, that's a good idea. Do you know if it's this section? Because I can go into that real quick.
I honestly don't know if it's in this section or not, but we're talking about moving from strings to ints, and I thought it was a good time to talk about it.
I think it touched on it.
Touched on it? Okay. It's honestly a lot like how we did in JavaScript, just of course with a different call, different function, different spell, whatever you want to call it. So let's go ahead and take our string here. Or no, let's take an int. Let's take our int. And give me a number. Who's got a favorite number out there?
Radical 3.
Sean, I swear once we're back in person. Whatever that is. Favorite numbers, give me a favorite number.
15.
15. All right. All right, 15. All right, favorite number is 15. So what we need to do here is if I want to say string fav num as string, and I say fav num, I'm trying to set an integer to a string. That's not going to fly because Java's like, what in the heck are you trying to do to me here? Required type of string provided was int. That is a no-go there. So what I can do is I can say string dot, what can I do here? I can technically just try to think of the other one. Okay, I'll do dot. I always forget this. Sean, you would bring this up. It's like, what is this? Is it string dot? There you go. Value of, yeah, value of for casting that. So there we go. We're going to console log that out. System.out print line fav num as string. There we go. And let's go ahead and make sure that works properly. I forgot while this is compiling too. Like I said, I'm always trying to be transparent with all of my knowledge here with Java. Java was one of my first languages that I knew way back in the day. So like I said, Java 6, I've been around for quite some time. My primary language though is JavaScript. So if I get a little rusty with Java, I apologize. However, if I should know a majority of the concepts that are questions that you want to know. It just might take me a second to remember. It's like getting back on that bike every time I go into this unit. And looks like we got it. We got 15 there. Fantastic. All right. So let's go ahead and convert it back now. So if I want to convert it back and say int, or we just say fav num equals fav num as string. Remember, we're going to get that error saying, okay, you were supposed to send me to an int, but you're sending me to a string. In that case, what we can do is integer dot and then parse int. Parsing is a way of looking at that string and saying, okay, is it a number or is it not? That's how we can parse it back here. Now, this is dangerous sometimes because, well, we'll take a look at it here first. So we're going to take favorite num. What we're going to do is we're going to paste it in here now, save that and run this. So everything should go honky-dory here. We're right at 7, so this will be my last example. Mark, to your comment about being a Scandinavian garage, I actually have finished misspelt in all of these lectures, apparently up until like lecture 7. So I don't know if I'm going to correct it, but Sean always made fun of me, or another TA, not even Sean, every single time, because I just could not spell finish for whatever reason. All right, looks like it ran. We got 15, but I will correct that if it is starting to annoy anybody. Okay, so let's go ahead and try to do one more thing here. So we're doing this. Regan, into parsing, not necessarily. This parsing is kind of just going to be right here. We're going to mention it. I don't know if I have it in any of my other slides. I can't guarantee that we're going to go deeper into it. Say if we want to try to parse pizza. We're going to go and see what's going to happen here. We run this. And we see we get our first exception. Now, we haven't gone into what exceptions are, but you've seen red in JavaScript. This means something went awry. Basically, for the input pizza, it was not able to parse it into a number, aka because pizza is not a number. So what this is that parsing is a very helpful tool, but it is also dangerous. So that's what I wanted to get here. So if you try to parse something that you know might not be a number, you're gonna have a bad day. So I'd say take parsing is a very good tool to use, but it can be dangerous sometimes. So that's what we want to talk about. We can talk about, or we are going to talk about how to deal with those dangers in the future. We're just not going to talk about it right now. But that is it, everyone.
Is the S there on line 12 trying to tell you that it's a string?
No, it's yeah. Error. Are you talking about in the error? Or are you talking about in the code?
In the code.
Greg, I'm sorry. Okay. No, it's not trying to tell you it's a string. It's just saying that's the parameter. That's the parameter name there. That's what that gray is. And I did not forget. I apologize, Greg. I'm using all your time. I'm going to pass it over to Greg here for our chit chat. Yes, our guest speaker here.
Yeah. So this will be really quick. I'm going to let you all get to your TA groups. We welcome to Unit 2. Really excited for all of us to be here. And looking forward to getting to work with all of you.
Did Greg forget to pay his internet bill?
No, he's just still thinking about what he was going to say.
I thought I forgot to pay mine for a second. Wait a minute.
Perhaps he's not looking forward to getting to know us.
So again, I wanted to remind you that I'm going to be available, and then also reach out to Taylor if you are a success coach, if you have any needs outside of the class that would prevent you from being able to complete. You know, we're really excited.
Hey, Greg. We lost like an entire minute of your speech in there. You're probably going to just have to go ahead and start over. You were frozen up for quite a while.
I am sorry. My internet tends to go out with the weather. What I was saying is I'm around if you need any help. I'm going to have some office hours for the candidate engagement manager. If you have questions like what does launch code look like after the class, or general questions, or want help setting up a catch-up plan, please reach out to me. If you have questions about the curriculum, you know, Slack should be your first place to take a look, and help.launchcode.org. I know there were a lot of questions around assignments 4 and 5 in the first unit, and some of those answers were there on help.launchcode.org. So I want to remind you that that's a resource. If you have things outside of class, life events that you think might keep you from being able to complete the class, and there's any way we can help, please let us know. We have our success coach, Taylor. If you reach out to Taylor, you can set up a time to talk. We've gotten you this far, and I certainly think that everyone who made it into Unit 2 should be able to complete this class. And so I'm going to work with you as hard as possible to make sure that happens. If you have any questions, feel free to reach out to me on Slack. We did change just a few people in TA groups, but you would have already received a direct message from me if you were affected. Just consolidating a little bit because of the lower number of students, and we had a few TAs who had to leave. Also added a couple new TAs. So be sure to welcome TA Alex and TA Derek to our class. We're really excited to have them.
Awesome. All right, thanks, Greg. And that is it, everyone. That is all I have for you tonight. So thank you, everybody. Great to see you all again. Looking forward to Unit 2 with all of you getting Java, and have fun and studio night. Remember that studio review will be posted on YouTube at 8:15 tonight. If you have any questions, feel free to reach out to me. Other than that, I'll see you all on Monday. Have a fantastic weekend.
Thank you, Kyle. Thank you, Greg.
Stay off of the green scooters, Kyle.